Are you guys ready? Everyone have the forces homework out in front of them. Alright, so here's how to do this. Now, I only want you to do number one. You guys are going to do, the rest tomorrow, okay? But let me get you started with number one, so at least you have a context for it. Are you ready? Yeah. Alright, so, Tresca, what does number one say?
Object lies motionless.
Okay, so consider, here's some surface. It's the floor or the table or whatever, okay? And then you have a block on that surface, and it's just sitting there motionless. Is that cool? So, what it's asking you to do is draw something called a force diagram. We practiced these the other day. Let's do one now. So, what you're going to do is, over here, you're going to draw a dot, and this dot represents your object, your box in this case. Is that cool? So, in the open space to the right, go ahead and draw a dot. Okay. In the open space to the right, go ahead and draw a dot. Perfect. And then, from this dot, we're going to use arrows to draw the forces, that's the pushes and pulls, that we think are acting on this box. Okay? Give me one thing you know for sure is pulling or pushing on this box.
Table or whatever.
Okay? You got them both. Great job. So we know that Earth is doing what? So we write next to it F, telling us it's a force. And then, well, this is what's pulling it down. Earth on, I'm going to call it a block. Okay. Earth on the block. How's that look? Does that look good? Not too bad, right? And then what's the other thing? That's right. I'm just going to call it the surface. So this is the force of the surface on the block. How's that look? And what do you want to be true about the length of each of these? You want them to be equal lengths?
Yeah.
I fully agree with that. Okay? I fully agree with that. I'm going to put the little hash marks on there. You don't have to put them on, but I'm going to put them on. Hard or easy? So it's easy, right? No big deal. How'd it go? Good enough for government work? Oh, that's good. That's nice. Thank you. You want to do this? That's okay. Worry about it. We'll figure it out. We're good? Now, let's try another one. Okay, you ready? So, if you look up here, okay. If you look up here, can you see this little ramp that I set up here?
Yeah.
Now, we know if I put this card on here, what's it going to do? It's going to roll down, true?
Yeah.
So, but if I put this here like this, what do you notice about it? Is it rolling down?
No.
No, it's not. So, can we kind of visualize what might be the forces on this cart right here? Okay? So let's look at that one. So here's the ramp. Here's your block. In this case, we know it's a little upside down cart, but let's pretend it's a block. So let's draw the forces on this one. Okay, here's your dot. This is probably one on there. It's number 9. Okay, number 9. Check with your neighbor. What do you think the forces are? What are the things that are pulling and pushing on our block or our cart? Remember, it has to be a physical object. Okay, don't forget that. It has to be a physical object. So check with your neighbor, see if your neighbor knows. What might be some things that are pulling or pushing on this cart? Ready? Check your neighbor now, quick!
Wait, well,
Check your neighbor!
Well, Earth always uses the last one, or no?
Earth always pulls down on everything.
You would listen, you know we're on number 9.
Settle down.
No, it's not. You need to
Settle
know.
down.
We're on number 9.
I'm the copy now.
So what are we on? Oh, nine? Okay, draw it out.
What's the thing called, the slide?
It's a ramp.
I got a question.
Do what? Number 8? Oh, we don't do number 8. All right, who knows at least one? Who knows at least one? What's the Earth doing? Pulling it straight down, yes? I agree. So this is the force of the Earth on, we'll say block again, I know it's not a block. Do we have another? Do we have another force? It's gotta be more, right? Okay, the Jedi know, yes. Isis. Good. The question is, what way is the ramp pushing on the cart? Okay. Okay, so this is a cool thing. Okay, this is a cool thing. So if this ramp is flat, poor demonstration. What am I doing right now? It's like it's my first time. Ever. Here we go. All right, one more time. If this track is horizontal, which way does it push? Straight upward, true? But watch this. If I angle this way, what do you notice about the direction that it's pushing now? It's pushing now for you guys, that's up and to the right, correct? Do you think there's a relationship between the orientation of the surface and the direction the surface pushes?
Yeah.
Okay? Check with your neighbor. Okay? Check with your neighbor. Is there a relationship between the orientation of the surface and the direction the surface pushes? Check your neighbor now. See if your neighbor knows. Well, think about it this way. When it's flat, it pushes straight up. When it's angled, it pushes up and to the right. Oh. Give your head. It starts with a P, ends in perpendicular. Nailed it. All right, Jane, what do you think? Is there a relationship between the angle of the ramp and the way the ramp pushes? What'd you say?
I don't know.
You gotta know. So look at the orientation. When this is horizontal, which way does this push? Straight up, vertical, true? But look at this one. Which way do you think this one pushes now? Loudly.
It goes perpendicular with the surface.
Yes, write this down. Flat surfaces push perpendicular to the surface. Flat surfaces always push perpendicular to the surface. Is that cool? So we're going to draw it on here.
That's like the perpendicular to the or like this.
To the surface. Perpendicular to the surface.
Flat surface. Push
Flat surfaces always push perpendicular to that surface. Now, there's one more. There's one more. Because look, if these were the only forces, what would my block do? It would have to slide down. What is keeping my block from sliding down the ramp?
Friction.
Okay, it's got to be some sort of friction, right? Right? Friction is an anti-sliding force between two surfaces. Which way do you think the friction applies the force? Okay, not directly left.
No, one like this.
So which way do you think the friction supplies the force? So it's not sliding down, right? again, if you watch the car by itself, if you put it on the wheels, it rolls down. But I put it upside down and it doesn't slide because there's, right? So which way is this?
Parallel?
It is parallel.
Oh my god, now we just
Now, the nickname for this force is the friction. Okay? The nickname for this force is the friction, but this is still the force of the surface on the block. But this one, we know this is the anti-sliding force, we call this one the friction.
How do we know that that one is less than?
Oh, it doesn't matter, I just want you to draw the forces, the size stuff. Yeah.
Would they both still be equal though?
So, there's some other factors in here, draw them in a way that's meaningful.
Okay.
I mean, to be honest with you, the way this really looks, it's a little more complicated. Like, this one is to the right and up. So you would say, oh, it's to the right and up. And this one is to the left and up. And so what this means is that since your object isn't going anywhere, the left balances the right, and the two ups together balance the down. We're not going to get that into it tomorrow. Okay, we're not going to get that into it tomorrow. All right, how's that look to you guys? Does that look okay? It's super easy when I do it. So I'm going to do a transition, but we're not done. I'm going to do a transition, but we're not done. So don't get all squirrely on me. I'm going to be out tomorrow, and what you guys are going to do is you're going to complete this. I'm going to leave you with a number that is your responsibility to put on a whiteboard. Okay? So you're going to complete the sheet, put your number on a whiteboard. You're going to draw the picture and the forces just like this on your whiteboard, right? And then you're going to turn your completed thing in at the end of the period. Does that make sense? Listen, we're not done. Don't get all squirrely. Don't get all squirrely.
Can I put some holes in my paper?
You want to put some holes in the paper? You're so welcome. Okay, so here's one thing that we have to talk about. There are 4 words that you should be familiar with, and I would like to know what you guys think about them. And they are mass, weight, volume, and density. Mass, weight, volume, and density. Does that seem okay to you guys? Mass, weight, volume, and density. What I would like you to do right now is I would like you to check your neighbor, and I would like you to write on somewhere on some paper somewhere. I would like you to write your definition of mass.
I'm sorry.
That's all right, you're good. You okay? What is your definition of mass? So check your neighbor, see what your neighbor thinks, and I want you to write down a definition that I can read as I walk around. All right? Write down a definition for mass that I can read as I walk around. What's that? Anywhere's fine. Pull out a piece of paper, go up from here, right to
Yeah, it's
the
defined by,
What is that? You have heard this term mass before, right?
so.
What is mass?
Weight, all the
Is the mass the weight?
I just have to wait if something else.
If mass and weight were the same thing, we wouldn't have two different,
It's like how much stuff is on.
right? What is the mass of an object?
I'm tired of being sick.
Yeah.
I know, it does suck, doesn't it? You can't sleep good, so then you're just more tired, and you can't get better, because you...
You gotta get up and come over. More sick.
There are worse places.
Okay, well,
Yeah.
This is like this.
Yeah, well,
It is.
Royce.
Settle down.
You guys have
Settle down. Well, I'm not holding you here. I celebrate you guys every day.
That's not you specifically, but like, I'm in the superior administration.
I have nothing to do with that. As long as you guys know, I'm here for you guys. I'm celebrating you guys every day. All right, who's got a definition?
We even got a prison food. Just ain't got no uniform.
Ooh, I like where your head's at. Matter in it? What did you think? Matter? What is
I
matter?
said matter too.
Uh-oh.
Wait, what do you mean by matter?
How much it takes up time.
Like, the amount of like atoms in an object.
But I said.
The amount of atoms in an object?
That was both.
Is it the weight of?
It's like the amount of stuff.
Yeah, I'm asking about matter.
Density is how much.
Ooh, okay, hey.
Don't say it. That is cute, like, so she came up with the idea. Alright.
What happened?